Section 4.3 Maxima and Minima. This question gives us a function f of x equals x squared minus 9 divided by x squared plus 9 on the interval -5 to 5, and we need to find the minimum and the maximum value. Now when the question asks for the minimum or maximum, they want the y values. So in order to find these y values, we need the x value or the critical numbers. We need to find those numbers first. So in order to do that, we have to take the derivative. So that is a general direction for this problem. So how do you solve it? So the solution. First, you need to make some argument. Can we even get the maximum and minimum? If they don't exist, there's nothing to do. So first, you need to observe x squared plus 9 is never 0 because x squared is non-negative, and then you even add 9 to it, so it's greater than 0. Okay, so it's never 0, therefore the denominator is never 0. That means f is defined. So f, the domain of f is -infinity to infinity. And on the function that are given to us, or in particular a rational polynomial, is always continuous on its domain. So f is continuous on its domain, and in particular continuous on the interval that's given to us, -5 to 5. So the extreme value theorem asserts that the minimum and the maximum exist. Okay, so now we know they exist, we can continue on the procedure. What we need to do is we find its derivative. So f prime of x equals, and we have a quotient, so we call the quotient rule, right? So u over v, when you take the derivative, equals v squared u prime v minus v prime u. So we have the bottom, x squared plus 9 squared. The top, you take the derivative of the top, so 2x times the bottom. You subtract the derivative of the bottom. Okay, derivative of x squared plus 9 is 2x times the top. Now, make sure you do the calculation correctly. 2x times x squared, -2x times x squared, they cancel. 2x times 9, 18x, minus 2x times -9, 18x. So we get 36x divided by x squared plus 9 squared. So that is the derivative. So in order to find the critical numbers, we need to set the derivative equals 0 and solve for x. And how do you solve it? Okay, you multiply both sides by the denominator, you will get 36x equals 0. Therefore, x equals 0 is a critical number. So at f at 0, okay, is an extreme value or local extrema. So f of 0 is 0 squared. You plug it into the original function. 0 squared plus 9, you get -1. So f of 0 equals -1 is either a minimum or a maximum. We don't know, okay? We have to test it. Now, we only have one critical number. How do we find out the maximum or minimum and where it occurs? If you are not sure, well, draw the picture or use a graphing calculator to take a look at the graph. Okay, so f of 0 is -1, and the graph looks like this. So you don't know, okay, where's the maximum? So how do we find out? We have to use our knowledge. So first, derivative test theorem, okay? What does it tell us? It says if f prime is positive, then the function is increasing. If f prime is negative, then the function is decreasing. Okay? And it says if f prime equals 0, you get a local extrema. So we know, okay, this is, and it should be verified by the graph, is a minimum. We need to know where is the maximum and how do we get the maximum. So we have to apply this theorem that we know. So we have to check, we have to rely on our knowledge of this f prime of x, which is 36x divided by x squared plus 9 squared. So when is it greater than 0? Is when, so you can take a look, okay, the bottom is greater than 0. So what determines the sign of f prime is the top. If the top is less than 0, the whole thing is less than 0. If the top is greater than 0, then f prime is greater than 0. So we realize that as long as x is greater than 0, f prime is greater than 0, therefore f is increasing, which happened right here. And when x is less than 0, plug it into f prime, right? Choose a negative number. You will realize f prime is less than 0, always. Look at the expression. And then you get f decreasing. And it's right here, it's decreasing. So that kind of guarantees us at the end point, you get the maximum. So you can just verify that by plugging in f of, let's say, 5. What do you get? You get 5 squared minus 9, 5 squared plus 9. So you get 25, subtract 9, 16. 25 plus 9, 34. So 16 divided by 34 is your maximum. And -1 is a minimum. So this and that is a solution to this original problem.